Hello all my dear students, welcome back to Prudence Coaching. In this particular channel, today we will learn about IUPAC nomenclature or IUPAC naming. After watching this video, I assure you will not have a single doubt from this particular topic. But before starting, we will go through the basic properties of carbon, which is very helpful for us to understand this topic. Students, do you know what is the atomic number of carbon? Yes, we all know. Because in the periodic table, we know carbon comes in the 6th position. That is hydrogen, helium, lithium, beryllium, boron, carbon. So it is coming in the 6th position. So its atomic number is 6. Can you draw the electronic configuration of carbon? Students, I think you all know it. It is very easy. So in the first cell, that is K cell, how many electrons can be there? Maximum 2 electrons, because we know by the formula that is 2n square. As K is the first cell, so here the value of n will be 1. So 2 into 1 to the power square, you will get here 1 square is 1 into 2, that is 2. So maximum in the K cell or the first cell, 2 electrons can be there. In the next cell, that is the second cell, how many electrons can be there? 2 into 2 square. As it is the second cell, so the value of n will be 2. So 2 square is 4, 4 2s are 8. That means in the L cell, maximum 8 electrons can be there. But here the atomic number of carbon is 6. That means total 6 electrons of carbons are there. So 2 is already placed in the K cell. Remaining 6 minus 2, that is 4, will be placed in the next cell, that is L cell. So here 1, 2, 3 and 4. So how many electrons are there in the outermost cell of carbon? That is 1, 2, 3 and 4. 4 electrons are there in the outermost cell of the carbon. That is the valence electron of carbon is 4. Now, to attain the octet, what will carbon do? Carbon has 4 electrons. To attain octet, it must has 8 electrons in the outermost cell, but it is only 4. So what are the two options left with carbon? Either carbon can give away these 4 electrons so that it attain the doublet, but it is not possible. It will require too much of energy. And other option is it can take 4 more electrons so that it may attain the octet, but it is also not possible because then also it will require much energy. So what will carbon do? As carbon has 4 electrons in the outermost cell, it has many disadvantages. That is, it cannot give away electron and it cannot take 4 electrons to attain octet, but it has an advantage also. What is the advantage? It can share the electrons with other carbons to form the octet. So what can it do to attain the octet? It can share its 4 electron in the outermost cell with either with the other carbons or other atoms of other elements. So to be stable, it has to attain the octet. How it is going to attain the octet? It can share its 4 valence electron, that is the electron in the outermost cell, with other atoms. For example, if we take hydrogen, hydrogen has 1 electron, that too in the outermost cell. So if we bring 4 hydrogen, if we place a hydrogen here, another hydrogen we are placing here, and another hydrogen we are placing here. So what happens by placing here? As you can see now, by placing this hydrogen here. Now if this carbon and hydrogen share the electrons among themselves, how many electrons will be there with carbon? As you can see here, 1, 2, 3, 4, 5, 6, 7, 8. That means carbon is having 8 electrons in the outermost cell now after sharing its electron with the electrons of hydrogen. So here now as you can see, hydrogen is having here 1 and here 1. That means this hydrogen is having 2 electrons in the outermost cell. So it has attained its doublet. So it is also stable now. Here also 2, here also 2, here also 2. Both the atom of carbon and hydrogen has attained the stability by sharing the electrons among themselves. This bond which are formed by sharing the electrons are known as covalent bond. So here is one covalent bond, single covalent bond, here one, here one. So here carbon is forming covalent bond with hydrogen to attain its stability. Similarly, carbon can attain the covalent bond with oxygen to form its octet. Similarly, carbon can form covalent bond with nitrogen to form its octet. Similarly, carbon can form the covalent bond with other carbon to form its octet. How? Here 4 electrons of carbon will be shared with 4 electrons of carbon. So these are the ways it can attain the stability. So here we came across 2 properties of carbon. So what are the 2 important properties of carbon? One is carbon has 4 electrons in the outermost cell, or the valence electron of carbon is 4. And another one is catenation. That is, carbon can form a covalent bond with. Let's use an easiest example to understand this topic. Here, if we draw a carbon like this, we know a carbon has 4 valence electrons. That means 4 electrons in the outermost cell. Similarly, if we draw another one carbon here with 4 valence electrons like this, we know these 2 carbon can combine with each other by forming covalent bond, because according to the property of catenation, 2 carbons can combine with each other using covalent bond. So if we draw a covalent bond, then these 2 carbon can be combined. So here this bond is known as single covalent bond because it is formed by sharing only 2 electrons, one of this carbon and another of this carbon. Now, as you can see, there are more valence electron in both the carbons. Now, if we bring hydrogen here, as hydrogen has 1 valence electron, so we are giving each valence electron of carbon 1 hydrogen. So we are writing hydrogen here, here also 1 hydrogen, here also 1 hydrogen. Now, as you can see, if we look at this particular carbon, then you will find how many electrons are there now after sharing its electron with carbon and hydrogen. Here you can see that 2 electrons, here 3, 4, here 5, 6, 7, 8. Now this carbon is having 8 valence electron. Similarly, if we look at this particular carbon, you will find here 2 electrons, here 2, 4, 5, 6, 7, 8. So here both the carbons have attained its octet. Now here hydrogen has also shared 1 electrons with carbon, so it has also attained its duplet. So here you can see this is a compound which is formed by sharing the electrons, that is using covalent bond, and here we find only carbon and hydrogen is there. So a compound which is only composed of hydrogen and carbon is known as hydrocarbon. So this is hydrocarbon. How you can rewrite this particular compound? Let's see. So we can draw this hydrocarbon. First we will do two carbons like this, and between them we have a covalent bond. Two electrons are shared, that means it will form a single covalent bond. Here we have one single covalent bond with hydrogen. Here we have another single covalent bond with hydrogen. Here we have one single covalent bond with hydrogen. Similarly here one. Similarly here one, and here one. So you can draw this particular compound like this. Now as you can see here, how many carbons are there? Two carbons, so C2. And how many hydrogen are there? 1 2 3 4 5 6, so H6. So you can write this compound as C2H6. Now how we can name this compound? So how many carbons are there? 2. Now if we see this tabular prefix, we will find one carbon, means we will use the prefix meth. If two carbons are there, we will use the prefix eth. Similarly 3 carbon means prop, 4 carbons means but, 5 carbons means pent, 6 carbon means hex, 7 carbons means hept, 8 carbons oct, 9 carbons non, and 10 carbons means dec. Now, so here as you can see, two carbons are there, so we will use the prefix that is eth. So we will write eth first. Now how many bonds are there in between two carbons? We have one single covalent bond, so we will use N, eth N. Why ethane? Because as you can see here, if the bond between two carbon is single, if one covalent bond is there between two carbon, we use the suffix N. So this compound which we have drawn is ethane. If it was two covalent bond in between carbon, we would use in, ENE, in as the suffix. If three covalent bond like this 1 2 3 in between the carbons, then we would have used ine, YNE. But here as you can see, we have only single covalent bond between these two carbons, so we will use ANEN. Two carbons, so we will use eth, and as single bond is there between two carbons, so N. So this compound will be named as ethane. So let's start with the next example. As you can see here, we have two carbons, and here we have only hydrogen and carbons, that is hydrocarbons. Here we have two carbons, one carbon means meth, two carbon means eth. So we will use the prefix here, that is eth. Now after this you can find that here we have two covalent bond in between these two carbon. So one bond means N, two bond means in. So we will use here in. So here our answer will be ethene. Now let us move on to the next one, number 3. As you can see here also we have two carbons. One carbon means meth, two carbons means eth. So here we will use the prefix, that is eth. After this you will find here that 3 bond or 3 covalent bond are there in between two carbons, and we know one bond means N, two bond means in, and three bond means ine. So here we will use ine, YNE. So here this compound will be named as ethyne. Now let us move on to number 4. So here as you can see only one carbon is there. So one carbon means meth. So we will use the prefix, that is meth. After this you will find here that here all the bond are single covalent bond. So we will use ANEN. So here our answer will be methane. So as you can see, these are the homeworks which you are going to solve at your home today, and you are going to share the picture of this homework in the Telegram group, the link of which will be given in the description box. So I think till this it is clear to everyone. In the next class we will be starting with the functional group and how we can use this functional group in IUPAC nomenclature. We will see in the next class. Till then, practice well. See you in the next class.